This is a review of the real number system. So if you needed some extra help or needed a refresher on the real number system, this video is for you. All right, so remember the real number system is composed of two parts. Your first part is going to be your rational numbers. And then you have the opposite of rational numbers, which is irrational numbers. So if you're in the real number system, you're going to be rational or irrational. And we know irrational numbers that consist of pi, our non-perfect squares, like the square root of 7, our non-terminating decimals, so like 0.23689 ... This goes on forever. So our non-terminating decimals and non-pattern decimals. So that is what the irrational side contains. If you are rational, we know rational has more options. So this is where we have our fractions, decimals, percents, decimals with patterns, and our terminating decimals, and perfect squares, perfect square roots. But we also know rational numbers have subset categories. So we're going to break apart those subset categories to begin with. So all the way at the bottom, we have our natural numbers. Remember, natural numbers are numbers how you normally count. So if I asked you to count to 3, you would just say 1, 2, 3. That's how you naturally count. So these are our natural numbers. As we move up in our real number system on the rational side, your next step would be whole numbers. So whole numbers contain all your natural numbers. That's going to be your 1, 2, 3. So we just move those up from natural. Then they also, choose a good color, let's do pink. They also contain 0. So the difference between whole numbers and natural numbers is the addition of 0. So we can say all of our natural numbers are contained in our whole numbers. That is a true statement. We cannot go the other way. We cannot say all of our whole numbers are contained in our natural numbers because the natural numbers do not have a 0 in it. Okay, so make sure we're not getting these confused. You can always move up when we're talking about the different subsets of the real number system. You cannot move down. Okay, so our next level is our integers. So our integers contain all of our whole numbers. So that's our 0, 1, 2, 3. They also contain all your natural numbers because that's our 1, 2, 3. And then what makes integers different is the fact that integers also have your negative numbers. Or you can say your whole numbers and their opposites. And we know opposites just mean the negative. So these are your integers. Okay, so all of your whole numbers are contained within the integer set. All of your natural numbers are contained within the integer set. Okay, so like I said, as we move up, they just keep on building. We cannot say that all of our integers are in our whole number set because the whole numbers do not contain negative numbers. And the same reason why we cannot say all of our integers are in the natural subset, because natural numbers do not contain 0 or the negative numbers. But remember, we can always go up. All of our natural numbers are in our whole numbers. All of our whole numbers are in the integer subset as well. And we're going to go up one more level to our rational numbers. We're back at rational. So rational numbers are going to contain all of our integers. So give me a second to write all these out and put the color variation up there. That might help with getting the point across. Okay, so all of our integers are contained within our rational number piece. But then we also know rational numbers, they contain our fractions. So we'll just do like 1/3. Contain our fractions, our terminating decimals, so decimals that stop, like 0.25, our pattern decimals, or decimals that repeat, so we can just do 0.33, decimals that repeat, our square roots of perfect squares, like the square root of 16. You can have your percents, so let's do like 50%. You can have your perfect squares, 4 squared. And I think that is about it. Oh, also absolute values. It's like the absolute value of 8. Okay, so all of these are in the rational column. Okay, so once again, as you move up, everything moves up as you go up a level. When you go down, it doesn't work. I cannot say that all of my rational numbers are integers because I also have fractions. I have decimals. Those are not integers. Okay, but I can say all of my integers are rational numbers because anything on this side is a rational number. So remember, we're dealing with the real number system. Everything is a real number. So you're either rational or irrational. So all these numbers are real. Everything is real. If you're real, you're either rational or you're irrational. If you're irrational, these are examples of what you can be, and it stops. If you are rational, you can have possibly the subset of being an integer, a whole number, or natural. Okay, and to do that, you just go back and forth. So for example, let's say I have 18/3. Well, 18/3, it's a fraction, so it is rational. So I can say this is rational. I'll just use RAT for that. It's rational. 18/3, if I reduce that, that equals 6. Well, 6 is also an integer. 6 is also a whole number. And 6 is also natural. So I'm just going through the steps. Let's say I have another example. Let's say I have 2/3. And also, this is also real. Remember, everything is real. We don't want to forget that. So 2/3. 2/3 is a real number. So now that I know it's a real number, It's either rational or irrational. So 2/3 is a fraction, therefore it is rational. From that point, I want to check my other categories, my other subsets. So 2/3 is not in the integer category. It's not in the whole number category. And it's not in the natural category. Therefore, 2/3 is just real and rational. Okay, let me erase this part. I'm going to leave the chart up and do another example. So remember, the best way to learn this is just to keep going over your definitions, going back over your classwork, doing those practices, doing the always, sometimes, or never, just to make sure you have the full understanding of this system. Okay, let's do orange. All right, now let's say we have an example with a set of numbers. So I'm just going to call this example sets. So if I have the set of numbers, let's say I have 2, 2/3, and 4 and 0. And I want to know which categories or which subsets of the real number system best describes this whole set. I'm going to look at what categories each of these numbers fall into, and it has to apply to all. So this was a quiz question that a lot of us missed because it did not apply to everything. So first, when I look at this set, I know it's a real. These are all real numbers. If it's real, then I know it's either rational or irrational. So I have 2. 2 is on the rational side. 2/3, my fraction, 4, 0. These are all rational numbers. And if it's rational, I want to look to see if everything applies to different subsets of the rational side. So 2, okay, well 2 can be natural. 2 can be a whole number, 2 can be an integer. So I'm going to keep that in mind. Now I go to 2/3. Well, 2/3 is rational. It's a fraction, but 2/3 does not fall in the integer column. It does not fall in the whole number subset, and it does not fall in the natural number subset. And because of that, if I'm saying find a subset that applies to all that is in this group, I have to stop at rational because that's how far I can go. They're all real, they're all rational. These two titles apply to everything in here. Okay, so let's do another example with the set. So let's say I have the set the square root of 4, 0, -3. And I want to find the subsets that apply to everything in this set. So I know they're all real. So if it's real, I want to go, is it rational? Is it irrational? These are all rational. So I can put that. And then I want to see if I can break it down. So rational. So I'm going to start with the square root of 4. So my perfect squares are rational. But then I'm going to ask myself, can I simplify the square root of 4? Yes, the square root of 4 is equal to 2. So now that since it's equal to 2, let's see if it applies to any of the other subsets. So 2 is an integer, okay. 2 is whole, and it's natural. So 2 can be rational, integer, whole, and natural. Okay, so now let's look at 0. 0 is rational. Okay, we already know that. It's an integer, and it's a whole number, but 0 is not natural. So far, I can't use natural. And then -3. So -3 is rational. It's an integer, but it's not a whole number. So therefore, all of them have in common, they have that they're rational and that they're integers. So integers. They all fall in the integer subset. If it helps, you can write the subsets next to each number and then see which ones they all match. So let me do that in green. So we said 4, so this is rational. We already know that it's rational, so we said this is an integer, this is whole, and this is natural. 0, we said it's rational and real, so we already have that. So it's also an integer, and it's whole. 3 is rational and real, and it's also an integer. Okay, so they all have integer in common, so I can use integer. They do not both have, all 3 do not have whole number in common, so I can cross that out, and they do not all have natural numbers in common. So therefore I can cross that out too. And what's left is just integers. So yes, this set, the categories or the subsets that best describe this set of numbers is that they are all real, they are all rational, and they are all integers. Okay? So once again, this is the real number system. If you are a real number, you're either rational or irrational. If you're rational, you might fall in the subset of being an integer, a whole number, or a natural number. Okay, so if you still have problems with this unit or this topic, just remember it's a vocabulary unit. Do you know your definitions? And if not, keep studying and practicing those definitions and rewatch this video.